Dear students, today we are discussing on measures of dispersion. Up to the last class we have discussed about measures of central tendency. What are the measures of central tendency? Mean, median, mode. In mean you have arithmetic mean, geometric mean and harmonic mean. So now we move to the session on measures of dispersion. So what is actually measure of a dispersion? What is dispersion? So let us look at some example so that you can understand in detail. Okay, let us think about a data 1, 2, 3. What is the central value? Central value is 2. Okay, so what is the deviation of the observation from central value? This is -1. This is 0, so this is 1. So these are the observation x values. This is the mean and this is x minus mean, deviation of the observation. So what is the total of this deviation? Total will be here, it will be 0. What will be the, so you can see that here we have deviation in individual cases. At the same time you can see that the total deviation is 0. So we cannot take this total as measure of deviation because this total is 0. Okay, so we can it is not meaningful. So to avoid this problem, we can think about the situation, that is we are taking the mode values x minus mean. Okay, so what will be the value? 1, 0, 1. So what will be the total deviation? So that will be 2. Okay, that will be 2. Similarly, we can consider another measure, that is we are taking the deviation and squaring it. So what will be the values? Again 1, 0, 1. So total value will be 2. This is also giving some idea about dispersion, that means deviation. So if it is a positive number, we can say that some deviation exists. Yes, it is true, because here we can see some deviation exists. Okay, so based on that value, based on this type of values, we can find out, we can say that there exists some deviation in observation when we take the deviation from the mean or median or mode. What are these? In this example I am giving only deviation from mean. You can take the deviation from median and you can take the deviation from mode, etc. So this is a measure. This value gives an idea about the deviation. Okay, you can think about another situation. Suppose this data is, okay, let us consider this one with another set of data. And this is actually this observation minus this one. Okay, this is the mean value. Okay, so this is actually okay. So now we consider another set of data. 3, 2, 4, or 3, 2, 5, 6. 3, 0, 2, 4. Okay, so what is the mean? Mean is again 2. Okay, mean is again 2. So what is the difference? Minus 2, 0 and plus 2. So the what will be the mode values? 0, 2. Okay. So what will be the total? 4. In this case, what will be the deviation? This will be 4. This will be 4. So here we are getting 4. That means 4 is nothing but mode x minus mean. Here we are getting the just deviation, and when we sum it, it will become 0 only. Okay. So if we take mode here, we can get a positive number, and this positive number means that there is some deviation of the observation from the arithmetic mean. Okay. And this 8 also says some idea about there is some deviation. So we can take the based on this 8, we can say that this data set is more deviated from the its central value than the first data set. Okay, it is correct, because for the first data set this value is 2, and for the second data set is this value is 8. So 8 implies that the deviation is more in the second data set than the first data set. So this can be considered as, that means sum of this x minus mean square can be considered as a measure of deviation. Okay, this 8 shows that the observations are much deviated from the central value, and this 2 shows that the observations are deviated very small from their arithmetic mean. Okay, that is correct, because the arithmetic mean is 2 and the observations are close to 2. Okay, so you can look at the for a pictorial representation. Let me give galaxy. Have you seen the galaxy? Galaxy. Okay. So what is the speciality of this galaxy? Here the observations are around the central value, but more deviated. But at the same time, here here also you can see the observations are centered about the central value. Okay, so this is the okay. So that means center the observation. Yeah, it is. The observations are much deviated from the central value. Okay. So the question: how much it is deviated? How much the observation are deviated from the central value? In this case, we cannot say it is 2. We cannot say it is 1. How much deviated means we can assign a measure. The measure of this value is h compared to the first set of observation. So this measure says that the degree of deviation. It says something about the degree of deviation. This is highly deviated. At the same time, you can consider one more example. This is 0, this is 50, this is 100. Okay, so what will be the deviation? This is 50. Central value will be 50. Okay, so what will be this x minus mean is minus 50, 0, 50. So this 0. This value will be 50, then it will be 50, so it will be 100. What will be this value? Okay, so this is, so in this case it is 5000. Okay, so it says that the observations are, this 5000 says that observations are very much deviated from the central value. Yes, it is correct. The central value is 50 and observations are 0, 50 and 100. So this can be considered as a measure, or this can be considered as another measure. Okay, based on this or this value we can compare the measure of dispersion of the observations. So that is the idea of studying the measures of deviations or measures of dispersions. Okay, so there are several measures of dispersions available in literature. So what are the commonly used measures of dispersion? One is range, another is quartile deviation, another is mean deviation, another is standard deviation. Okay, so let us consider these four measures of deviation. One is range. Okay. Range is nothing but the difference between last and first observation. Okay, so here also we can consider range. What is the range? Range value, this is 2. Okay, range is 2. So range is 2 for each and every observation. Okay, or range we can consider only one value. Okay, range is 2 here. What is the range here? Range is 4 minus 0, that is 4. Range is 4 in this case. What is the range in the last example? This is 100. Okay, so that based on this range we can measure the degree of deviation. So first example is, first measure is range. Range is nothing but the difference between greatest and smallest value. Okay, so this is one measure of dispersion. This measure says the data is deviated much or less. In this example, this range is 100, that means data is much deviated, and this deviation, the maximum deviation is 100. This says 4, that means the difference between data, the deviation of data, maximum deviation is 4. Okay, this is another, this says that the maximum deviation is 2. Okay, so range can be considered as a measure of deviation. Okay, another is to compare with a set of observation. We can consider this relative measure. This is a relative measure of deviation. Okay, so in this case we can find out the relative measure as relative measure of deviation, relative range, that is 2 by what is that, 4. Okay, that equal to, actually equal to this is 2 by 4. So that okay, 0.5. 2 by 4 means 0.5. Anyway, here the value of range is 2 by 5. Here the value of relative range is 4 by what is that? 4 plus 0, 4 by 4 plus, that is 1. Here the range is 100 by 100, that is also 1. Okay, so we can compare these observations. So this is the, so coefficient of range is L minus S by L plus S. Okay, so here we can see one example. The price of share of a 6-day week is fluctuated as follows: 156, 165, 148, 159, 147, 162. Calculate a range and its coefficient. So here the highest observation is 165, smallest observation is 147, that difference is 18, that is range is 18, and the coefficient of range is L minus S by L plus S, that is 0.0577. Another example is calculate the coefficient of range from the following observation. So the observations are given in a class interval 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. Whatever be the class interval, the lowest limit is 10 and highest limit is 60. So we need only that information. We don't want the frequency information. Anyway, we can use this data, and coefficient of range is L minus S by L plus S, that is 60 minus 10 by 60%, that is 0.7143. Okay, so this can be considered as the measure of dispersion. Okay, and it has some merits and demerits. You can read that. It is the simplest to understand, the easiest to calculate. It is used for statistical quality control. There is an area of statistics you will study in MSc classes. And demerits means its definition does not seem to suit for calculation of data which class interval. Further, it cannot be calculated for open-end data. It is based on two extreme values, lowest and smallest are considered, and we are not considering all other items. It does not have sampling stability. Further, it is calculated for samples of small sizes only. It could not be mathematically manipulated further. It is very rarely used to measure. It's very rarely used. We are not using always. We are using always standard deviation or mean deviation. So range is a measure that's introduced at the beginning of statistics theory. Okay, as a first information. Okay, so that are the merits and demerits, and you can write the things what we have discussed till time, and you can submit in the Moodle platform. Okay, I think you have worked out the problems in the previous chapter. As far as possible, you do the problems and submit according to your availability of the time. That will be helpful for writing the examination in detail. That will help you in examination. If you work out these exercise problems, that will help you in this examination and in the future examination what we have trying for the job higher studies. Okay, so students, you study this.